Hey everybody, this is Mr. Martin, and this is the the kinetics bit where we're dissolving an Alka-Seltzer tablet in different temperatures of water. Okay, so let me adjust the camera a little bit. Hopefully you can see that. This is the ice bath water. I've got a digital thermometer here. I will call out the temperature and the times involved. So the ice bath water, we are at, looks like 7.0 degrees Celsius. Okay, so I'm going to go ahead and drop the Alka-Seltzer tablet in. I'll tell you when to begin timing and when to stop timing. You can start timing when I drop it in. So I'm going to drop it in 3, 2, 1, drop. Okay, I don't know how well you can see that, but it's effervescing nicely. And bubbling away, bubbling away. Yeah. At this point, all we can do is watch it bubble. It's really not all that exciting, but there it is. Okay. Interesting. So going along, I can still see the tablet is mostly intact down there. Pointing out here as we do this that making sure that we use an intact tablet every time. That way we know that we have similar conditions in every case. Okay. Still bubbling a little bit. The other thing we're not going to do is shake or otherwise agitate the container. I'm just going to let it sit until it's done. And I see no more large chunks. We'll call that done. So stop timing. Okay, there we go. That's one trial. Trial number 2 is one that I had in the refrigerator, and I've got the digital thermometer here, and it says 6 degrees Celsius. Okay, so 6 degrees Celsius for that one. And again, let's drop a tablet in 3, 2, 1, start. Double, double, toil and trouble, all that jazz. I don't know if you can hear it at your end, but I can certainly hear the fizzing as this reaction goes on. As you know from the pre-lab questions for this experiment, one of the products of this reaction is carbon dioxide, and so that's what causes the bubbles. We're actually going to talk about carbon dioxide this week in terms of a reversible chemical reaction. Carbon dioxide in your bloodstream actually plays an important role in regulating your blood pH, which is useful. Okay, and this is still going along bit by bit. Still got a pretty significant chunk in there. So as I'm watching, I'm kind of watching to see when the biggest chunk breaks up and when there are no more significant sized pieces. And looks to me like the last piece is gone, so stop timing for this one. Okay, our next water is one that's been sitting out just on the counter all day. It's room temperature. It's 20.6 degrees Celsius. Again, we'll begin timing in 3, 2, 1, drop. Oh, and this one's going along quite a bit quicker, it sounds like, and looks like. Okay. Can you hear that? I don't know if you can hear that or not, but I definitely hear it. And that one is done. Stop timing. Okay, next I have a beaker that's got some hot water that I got out of the sink. This one is 34 degrees Celsius. Okay, and let's drop our tablet in there in 3, 2, 1, drop. Oh, and that's dissolving away nicely. And again, to point out, this isn't just a matter of dissolving, this is an actual chemical reaction. It's a neutralization between citric acid and sodium bicarbonate. And done. Stop timing. All right, finally, I have some water that I heated up in the microwave. And this one, it was boiling when I put it in, but it's cooled down. It's now at 55 degrees Celsius. And we'll drop it in 3, 2, 1, drop. And that is really going to town. Done. Stop timing. Okay, you have the temperatures now. You have measured, or theoretically could go back and now measure the times it took for the reaction to take place in each case. The instructions are there for you as to how to construct your graph. Happy data plotting, and we'll talk to you later.